This video is going to be all about cooling fans. Specifically, is it a good idea to take a thermostatic clutch fan off an engine and put an electric fan in its place? Well, let me take this one off and we'll talk about that a little bit. All right, on your right is a stock thermostatic clutch engine-driven cooling fan. On your left, we have a 16-inch electric cooling fan. When is it a good idea to take this off and put this on? So really, I can think of three situations where you might want to go with an electric fan. If you're trying to squeeze the absolute last possible horsepower out of an engine, you might want to run an electric fan. If you're trying to squeeze the absolute most possible fuel economy out of a vehicle, you might want to run an electric fan. And if you're working with some sort of a custom vehicle that doesn't have a stock option, sometimes it's easier to work with an electric fan. However, there's a lot of drawbacks to going electric, and let me talk about a few of those. The biggest single drawback to converting to electric is there is no way that this little electric engine fan is going to cool as well as this engine-driven thermostatic clutch fan. Let me give an example. Most engine-driven thermostatic clutch fans at peak horsepower, when the fan clutch is off, are drawing around 30 horsepower. That's with it off. Imagine how much this fan consumes or uses when the clutch is on and it's activated. It's using quite a bit of horsepower. This electric fan, this fan is about a 10 amp fan. It's about 1300 watts. If you convert that to horsepower, it's less than 2 horsepower. This electric fan will never keep up with this engine-driven thermostatic clutch fan. It can't. There's no possible way that this fan will do what this fan can do. It's that simple. Now, having said that, there's a lot of situations where an electric is acceptable. Depends mostly on the vehicle it's in, how much horsepower the engine is making, and the way the fans are installed. So a good relationship for airflow is current draw. The more current draw the fan has, the more airflow typically that it will move. So if you look at some stock options, like TARS, for example, is a good option. That fan pulls about 40 amps. This only pulls about 10 amps. So a stock TARS fan is going to do better than this fan. Unfortunately, I didn't have room for a TARS fan in this application, but such as it is, if you do have room for a stock option or a fan that draws more current, you'll be in a better situation. Find one that pulls 30 or 40 amps. You'll be better off than these cheap aftermarket fans that only pull 10 amps. So that's one thing to be aware of. The more amps the fan will pull, the better chance it will have at cooling the engine. Another good experiment is to make sure that your particular vehicle doesn't have an airflow issue. The easiest way that I found to do that is to remove the fan and get out on the freeway and see if it overheats. If your vehicle overheats at 55 or 60 miles an hour, it's probably got an airflow problem. There's something restricting airflow through that condenser or radiator, and you might want to address that first before you start looking at fans. Sometimes it could be something as simple as a missing air dam. Sometimes it could be a little bit more involved, like the radiator or the condenser you've chosen, or the airflow that's getting into the engine compartment has to have a way to get out, so sometimes you have to address those issues first. In my case, what I found on my particular vehicle is that in the summertime here, when it's 110 degrees, this fan simply isn't enough. So what I do is I run this fan through the summer, and then about this time of year, this is October, I will switch to the electric, and I will run the electric all winter long, and then in the spring when it starts to warm up, I will throw this fan in the back, and it will probably get put on somewhere around end of March. So this fan operates just fine without a shroud. That's another thing we need to talk about. Whenever you're dealing with a thermostatic clutch fan, it should have a shroud attached to it. If it doesn't, it may not work properly. So a factory shroud with a factory fan is probably your best solution. But thermostatic clutch fans have a lot of variables. For instance, are you running a drag car where you've put a higher differential gear and now the engine is turning 3,500 RPM at 65 miles an hour? So, you know, when that engine was stock and the rear end was stock, a thermostatic clutch fan at 70 miles an hour might have only been turning, the engine might have only been turning 2,000 RPM. This thing was barely luffing along. It wasn't consuming hardly any horsepower. Now you're turning the engine 3,000, 3,500 RPM, and it's consuming a lot more horsepower even when it's disengaged, when the thermostatic mechanism is off. It's still pulling more horsepower because it's spinning faster. A curious corollary to that is most new pickups have software in the PCM so that if you're towing a trailer or if you're just loading the engine however way on the freeway and the engine starts to overheat, the PCM will actually downshift the transmission out of overdrive into direct drive to speed the engine up because it knows that if it does that, it will help cool the engine down. Fan is spinning faster, engine is spinning faster, it's moving more air, cools it down. So a faster spinning fan moves more air, consumes more horsepower, and that's just a side effect of thermostatic clutch fans. Modern fans on a lot of vehicles are electronic and are actually engaged and disengaged by the computer, which is nice, but I haven't actually seen that hit the aftermarket yet. It would be a great thing if somebody tooled up and made a fan that you could control whether it's disengaged or engaged electronically in the aftermarket, but we haven't seen that yet. So that's basically the up and down of it. It's probably not a good idea to assume that taking a clutch fan off an engine and going to an electric fan is going to improve cooling performance. The likelihood is it's going to be just the opposite situation. You're probably going to degrade cooling system performance with an electric fan. But however, on my vehicle, I know that if I switch to an electric, and very important, I have to make sure that this fan is wired so that it's off until the engine needs it. So I've got this through a thermatically controlled switch on the thermostat housing that when this fan gets to a certain temperature, where this engine gets to a certain temperature, it will turn this fan on. And then on the freeway, when you're going 65, 70 miles an hour, you don't need this fan on, so it leaves it off at that point. The way that you achieve that is you make sure that the thermostatic switch that's turning this fan on turns on at a temperature that's at least 20 degrees higher than your engine thermostat opening temperature. So if your thermostat opens at 180 degrees, you'll want your fan to kick on at probably 200 plus degrees. That way, when you're cruising down the freeway and the coolant is being cooled by the radiator, as it goes through the engine, as it comes out the thermostat housing, if it's less than 200 degrees, which in a properly functioning radiator it should be, the fan stays off. Then as you slow down and you come to a stop and there's no airflow through the radiator, now you've got a situation where the coolant temperature just starts to increase and the thermostatic switch will turn the fan on. So you never want to wire one of these things directly to the battery for two reasons. One, it's going to consume power all the time. That's kind of what you don't want. When you switch to an electric fan, you want to improve the engine's efficiency. You don't want any drag on the engine. So if this thing is consuming 10 amps, that 10 amps is coming out of the alternator, which is a load on the engine. So set it up so that it's off when you don't need it. Never wire it direct. The second reason you don't want to wire it direct is because it won't live very long if you do. If it's on all the time, this little electric motor will wear out quickly. So not a good idea. You always want to set them up so they're not just turned on with the key. They're activated when the engine needs it, and that is typically due to engine coolant temperature. So I'm going to go ahead and put this one in, and we'll give it a try. I've got this wired up to install quickly, so if I'm out off-road somewhere, just out somewhere, anywhere, and I have this on, and I find out it's not enough, it's not a big deal for me to take it out and spin on the thermostatic clutch fan, so I can get it done pretty quickly. Here's my installed fan. It's a 16-inch fan. It's been molded to a bracket. It's been welded up to fit the stock mounting locations on the radiator. It's driven by a relay. The relay's right there. I've set it up so that it's easy to wire. There's my ground, and that supplies power. Here's my thermostatic switch right here. That's what ultimately turns the fan on. Thing you want to do when you wire these is make sure you get it wired in the proper polarity. And an easy way to check that is just with a piece of paper. It tells you that the airflow is in the correct direction. You'll notice that I don't have this thing wired to shut off with the key. I don't know yet whether that will be an issue for discharging the battery. If it becomes an issue, what I'll do is I will wire this relay to pick up its coil power from the ignition switch, and that will solve that problem. I think I'm okay because it's only a 10 amp fan and I've got a pretty good battery, but we'll see. Another thing that I wanted to mention is I don't think it's a good idea to put an electric fan on a trail rig. So you could imagine that you decide to go off-road, and for 3 hours you pick your way over rocks and gullies and hills and never exceed 5 miles an hour. And 3 hours from asphalt, the electric fan dies. That would be a disaster. So I think for trail rigs, an engine-driven fan is the way to go. So if I ever decide to go far off-road with this thing, and I do occasionally, what I will do is I will pull the electric fan out and I will put this fan on, and that won't be an issue. Another thing that I want to mention is what I said earlier about not needing an electric cooling fan or any fan at freeway speeds does not apply to tow vehicles. if you have a tow vehicle and you're pulling a heavy trailer, there are situations where you could be at 60 miles an hour on the expressway, and the load of the engine will be such that the thermostatic fan will kick in, and you'll actually hear it kick in. It sounds like a 747 taking off. And if you were to take that thermostatic clutch fan off and put an electric in its place, it probably would not work. So I think, once again, for tow vehicles, you want to use an engine-driven fan. So trail vehicles, you probably want to use an engine-driven fan. And for tow vehicles, you probably want to use an engine-driven fan. But electrics do have their place. I believe this will be worth a few miles per gallon on the highway. I'm going to go test that out shortly. But they don't work in every application. And don't be surprised if you take a perfectly good clutch fan off and try and refit it with an electric that it doesn't work, because it's entirely possible. But anyway, I hope you learned something from that. I had fun talking about it, so thanks for watching.